Okay, so what we're talking about today is graphing. Now, there's ways that you can do this with the graphing calculator. I'm actually not going to talk about how you can do all this stuff with the graphing calculator today. I want to talk to you about how to use Desmos. I think Desmos is a little bit faster. Let me rephrase. Desmos is way faster than your graphing calculator, but you can't use it on tests. So in terms of like, hey, I want to hurry up and get something done, it's great, but you need to know how to use your graphing calculator as well for a test. If you want to know how to do some of these things with your graphing calculator, you've seen all of it before. There are review videos by this guy, Rob, that I pulled off of YouTube and I posted on Schoology, so you can check those out. But to keep this video short, I'm doing this all on Desmos. So this first one, we need to find any intercepts algebraically and then use a graphing utility to verify. So graphing utility includes Desmos. So I'm going to show you how to do this on Desmos. It's real easy. You pull up desmos.com calculator. You can even log in if you want so that you can pull up your old graphs. All you got to do is just type it in. So it's, I've already forgotten. It is y equals 2x minus 5. Done. There we go. There's my graph. I can drag this around. It's really easy to get your nice window. And then if you want to know the intercepts, you can just click and then boom, there's my x-intercept at 2.5 and 0. And then here's my y-intercept at -5. Done. Other thing that we're going to talk about is testing for symmetry. So there's different ways you can test for symmetry. For the y-axis, if you want to find out that algebraically, other than looking at the graph, you plug in -x, so you do f of -x, and if that spits out the same function, it's symmetric to the y-axis. If you want to check if it's symmetric to the x, you slap a negative in front of your whole function and see if nothing changes. If nothing changes, it's symmetric to the x-axis. If you want to see if it's symmetric to the origin, you have to do both of those things separately and then see if there's the same. So you have to check x and y and see if they're the same thing.
Wait, oh, you want me to do two things? Man, I'd call my lawyer if dialing the phone wasn't such a hassle.
So once again, any x-intercepts or y-intercept is just going to be 0, as we talked about in the previous one. So y-int is going to be at 0, 0. So this one should go through the origin. In terms of my x-intercepts, I'm going to set 0 equals, and I'm just going to factor right away. So we've got x squared minus 4. That's a difference of squares. So that's x plus 2 and x minus 2. And x 0 equals. So our x-intercepts are at the origin. Well, we knew that. It already went through there as a y-intercept. It's an x-intercept too. Should have another one at -2, 0, and we should have one at 2, 0. Let's just check all that in Desmos first before we do that symmetry stuff. Desmos. Get rid of this last one. So I need x cubed minus 4x, I believe it was. Let me double check. Y equals x cubed minus 4x. Done. All right, great. So there's our nice cubic. So we've got our intercepts there. We got our x and y intercept at the origin. And then we've got our other x-intercept there. Now we want to test this thing for symmetry. So first thing to do to check if it's symmetric to the y-axis, we have to do that. Can we go back, please? We're going to put a negative inside of our function, replace x with -x, and see if nothing changes. If nothing changes, symmetric to the y-axis. So I'm going to replace that x with a -x. And see if nothing changes. So if we cube negative 3 times, it's going to end up being negative, oh, what is that? -x cubed. And then a -x times a -4 is +4x. Okay, So now that that's simplified, that didn't turn back into this. So it's not symmetric to the y-axis. And you can even see that on Desmos. If you use the y-axis here as a mirror line, it doesn't look the same on both sides. So that's no good. Well, in terms of y-axis symmetry. Let's check x-axis symmetry. So for this one, we're going to slap a negative in front of the whole thing and see if nothing changes. So we're going to do y equals, and we're going to put a big old negative in front of everybody, like that. So we get y equals, well, we could distribute that negative in, and we get negative x cubed plus 4x. Again, it didn't turn back into this, so it's not symmetric to the x-axis, which you can see if you look at the graph. If we took this thing and flipped it over, there's nothing there. If we took this thing and flipped it over the x-axis, there's nothing there. So it's not symmetric to the x-axis. However, you might have noticed, going back to here, that this and that are the same. Since these two things are the same, it is symmetric to the origin. It's symmetric to the origin since both of those things are the same. So you can kind of follow points as they hop over both axes. This could hop over the y-axis and the x-axis, and it's found a new friend. If this thing kind of like hops over the x-axis and the y-axis, it finds a new friend. This one, same thing here. If it flips up and then over, it's got something to reflect onto. So this is symmetrical to the origin, but not the x or the y. All right. Whew, that was a lot.